Hi, this is International Math Olympiad 1960th, the problem number 3. In a given right triangle ABC, the hypotenuse BC of length A is divided into n equal parts n and add integer. Let alpha be the acute angle subtending from the point A, that segment which contains the midpoint of the hypotenuse. Let each be the length of the altitude to the hypotenuse of the triangle. Question: prove tangent alpha equal to 4n each over n square minus 1 multiplied by a. If you want to try, just pause this video. When you want to come back to see how to solve this problem. Let's draw this triangle. We have the BC, segment BC. As the question says, this segment BC is divided by n parts are equal each other. As we know, we have the midpoint is located at the half of distance of this segment, this point, which let's call it M. We have also 2 points, Q and P. Since we have this equal distance of BC, because this segment BC is divided by n parts are equal to each other. So what does this mean? This means this BC equal the distance A equal n, because it's divided, n is divided by parts. So these parts are equal. What's this part? So it's divided by small segment PQ. Okay? So that means n equal PQ plus PQ plus PQ and so on until you go to last term PQ. Okay? PQ equal 1 plus 1 plus 1 plus 1. Why equal 1? Because n equal 1 plus 1 plus 1 plus 1 until you get the last term, right? The PQ, since we have PQ is a small distance, is equal this small part, which n divide this distance is divided by n. Okay, this is n. This n will be divided by segments, small segment, which are PQ. Okay, PQ is divided by n parts. Okay, that's mean all these parts are equal to each other. Okay, that's mean this small distances represent PQ as a segment. Okay, so that's mean BC equal A, distance A equal the n is an integer, add integer. So that's mean this A, this distance BC equal PQ plus PQ plus PQ until you get the last term PQ. Okay, it's divided by pieces, by parts. So that's mean PQ, since we have n equal PQ plus PQ, that's mean PQ equal 1 plus 1 plus 1 plus 1. You get the last term. That's mean PQ equal 1. But I don't want PQ. I want this distance MP and MQ. Since we know M is a midpoint of the segment BC, okay? So the M belongs to the segment, which is PQ is a part of these segments, which are equal to each other. Okay, what does this mean? That means this half distance, this one, this distance equal 1 over 2, because 1 divided by 2. So that means P equal 1 over 2, and P equal MQ equal 1 over 2. This small distance is 1 over 2, because we have midpoints, okay, of these segments. So let's transfer this one to the expression. Okay, now what's other information missing? Information is not given, but we can add it to solve our problem. So let's put A equal 0 0, B equal this one, is a B 0, C equals 0, C, small c, this is big C, okay? This is, let's put this one in coordinate plane, okay? Since we have a triangle, a right triangle at the point A, so we're allowed now to do the coordinate plane with origin A, okay? So the B is represent X axis, C is on Y axis, okay? So what's the question? The question to show this one, to prove this expression, right? As we know, what's the alpha? Let's before we do that, let's determine this point M, P, Q. Since we know M is a midpoint of the segment BC, that means we can express M as a XY coordinate. M equal what? Equal N over 2, because the whole distance of the segment BC equal N. That's mean midpoint. That's mean midpoint N equal N over 2. So what's N over 2? On X is an input, output is a N over 2 as well, because the half distance for this one the same, okay, the same. So what's the coordinate P? P, as you explained now, P is a midpoint and plus the half distance that I showed, that I proved, was 1 over 2, okay? So that's mean N over 2, okay, which is distance. That's the reason why I put this one, to understand this one. Plus 1 over 2, because they have very small distance between M to P, okay, which is this one, okay? So this is input, output point, which is this one. It will be the same thing, but remember, it's going to, see, this one, P is located below M, okay, on vertical axis, but this one is located after xn. So that what does mean? That's mean I have N over 2 minus this distance, because this distance, okay? What is Q? Q is this one. Here is an N over 2 minus this distance, which is minus 1 over 2. This one, what's the output of this one? Is an N over 2 plus 1 over 2. You can put it like this, N plus 1 over 2. But don't forget, is multiplied by the axis, or A-axis, which represents this distance, which is B. You have to multiply it by B. This multiplied by C, okay? The same thing. C, this is B, this is C. Because C represents X-axis, C represents Y-axis, okay? You can put it N plus 1 over 2 multiplied by the coordinate B, okay? Output, this is input, output, which is N over 2, N minus 1 over 2 multiplied by C. Same thing with here. So this one, P equal N minus 1 over 2 multiplied by B as a axis. This one, N plus 1 over 2, the C, the Y axis, okay? This is the important thing. Since we have N is an integer, okay? To keep this distance, this distances as an integer number, we have chosen N is an odd number. That's what the question says. So that's mean N, odd number, is written on this form, 2k plus 1. When you add 1 over to the other side, it become n plus 1 equals 2k plus 2, which is multiplied by 2, k plus 1 over 2, That's mean, what's the alpha? Alpha is this angle between QAP, this one is alpha, equal what? This angle equal this big angle, which is alpha 1, which is this big angle QA, capital A, B, minus this small angle, which is PAB, okay? Is noted by alpha 1 minus alpha 2, okay? I'm going to apply tangent here. So tangent alpha equal tangent alpha 1 minus alpha 2. What's the tangent alpha 1 minus alpha? We have this formula. Tangent x minus y equal to tangent x minus tangent y over 1 plus tangent x multiplied by tangent y. So this is exactly what I'm applying here. So now tangent alpha equal tangent alpha 1 minus alpha 2 equal tangent alpha 1 minus tangent alpha 2 over 1 plus tangent alpha 1 multiplied by tangent alpha 2. What's tangent alpha 1 equal in this case? Okay, tangent alpha 1 in x, which is distance xq minus xa, coordinate a, equal, we have it here, this one, equal alpha 2, it will be the same way, I will calculate in the same way as I did before. So tangent alpha 2 equal slope, change in y over change in x. Change in y is this one, yp minus ya, the coordinate a, coordinate p minus coordinate a, which is represent out point in this case, over changing in x, which is x p minus coordinate change in xa, okay? This coordinate p is determined by the alpha 2, okay? Alpha 2 is determined by point p. So the alpha 2 is determined by the point p, okay? As you see here. The alpha 1 is determined by the point q, okay? So this one yp, the output point is already calculated, which is this one, p, not q. We already did q, okay, for this one. So start calculating tangent alpha 2 in this case now. Let's move on to calculate tangent alpha 2, okay? So we already proved tangent alpha 1 equal to n plus 1 over n minus 1 multiplied by c over b. Let's move on to tangent alpha 2. It will be the same thing. So tangent alpha 2, same way, equal slope. That's mean change in y over change in x, okay? Change in y for the point, for the alpha 2, right? Alpha 2 is determined by the point P. Alpha 1 is determined by the point Q, okay? So this is small distance alpha 2, okay? It will be the same way. I will calculate in the same way as I did before. So tangent alpha 2 equal slope, change in y over change in x. Change in y is this one, yp minus ya, the coordinate a, coordinate p minus coordinate a, which is represent out point in this case, over changing in x, which is x p minus coordinate change in xa. Okay, this coordinate p is determined by the alpha 2. Okay, alpha 2 is determined by point p. So the alpha 2 is determined by the point p. Okay, as you see here. The alpha 1 is determined by the point q. Okay, so this one yp, the output point is already calculated, which is this one, p, not q. We already did q. Okay, for this one. So I'm calculating p, right? Okay. So this one is n minus 1 over 2 multiplied by c. This is 0 because 0, a is because the origin, a, x changing xp, which is n plus 1 over 2. Okay, this one multiplied by b minus 0, which is, let's simplify by 2 here, which is n minus 1 over n plus 1 multiplied by c over b. Okay, now let's plug in our expression here. Now in this step, as we know, we already calculate tangent alpha 1 equal to n plus 1 over n minus 1 multiplied by c over b. We know also tangent alpha 2 equal n minus 1 over n plus 1 multiplied by c over b. Okay, let's now calculate tangent alpha. As we know, tangent alpha equal tangent alpha 1 minus alpha 2, as we have in this formula. So equal tangent alpha 1 minus tangent alpha 2 over 1 plus tangent alpha 1 multiplied by tangent alpha 2. Alright? So this one is giving us, let's plug in this one into this one. So tangent alpha 1, this one, which is n plus 1 over n minus 1 multiply c over b. Okay, minus this one, n minus 1 over n plus 1 multiplied by c over b over 1 plus tangent alpha 1 is this one, n plus 1 over n minus 1 c over b multiplied by n minus 1 n plus 1. Okay, multiplied by cb. Okay, so this one you will simplify by this one, this one. So let's put this one, let's put c over b as a multiplier, c over b. Okay, so this, let's multiply this one by this one, which is n plus 1 square minus n minus 1 square over this one, n minus 1 multiplied by n plus 1, which is n square minus 1 over this one, which is 1 plus c square over b square. Okay, this one n square, let's make some simplification here, n square plus 2n plus 1 minus n square minus 2n plus 1 over n square minus 1 over here multiply by c over b always, here b square plus c square over b square. I'm running out of the room. I'm going to bring this one at the top and continue with our problem. Okay, now I have tangent alpha equal this expression. I'm going to cancel out some numbers and simplify other numbers, okay, as well. So now this one, n square minus n square, which is 0, 2n plus 2n is 4n, plus 1 minus 1, which is 0, c over b. This one, n square minus 1 over n square minus 1. This one I will bring it up, it become b square over b square plus c square. Okay, I'm going to simplify b by b for n c, for n b, for n b c now, over n square minus 1 multiplied by b square plus c square. Okay, now I found this expression, but I didn't finish yet. I'm going to make some changes in this expression now. As you see, b square plus c square, this is a right triangle. I'm going to apply the Pythagorean theorem. Okay, so as you see here, the right triangle, so ABC is a right triangle, so that's mean BC square equal AB square plus AC square, which is AB square, we already have it, which is B square small b plus C square. BC square we already have it, which is A square. Okay, now this is first equation. Now I'm going to calculate BC. What is BC? I'm going to use the area of the triangle. Now in the last step I have this expression, tangent alpha equal to 4n bc over n square minus 1 multiplied by b square plus c square. We already found this one. I'm going to plug in this one into this one here, and then also I'm going to calculate BC. Okay, what is BC represent here? I'm going to calculate the area of the triangle by using the coordinates. I'm calculating the area of the triangle by using another method. So the area of this triangle equal also 1 over 2 multiplied by the hypotenuse, which is BC, which is A, okay, multiplied by the altitude is the height of this one from point M to A, so which is H. Okay, now let's simplify this one by this one. Now BC equal A multiplied by H. Now let's plug in into our expression. So tangent alpha equal 4n multiplied by AH over n square minus 1. B square plus C square is a square. I'm going to simplify the A from this fraction for 4 multiplied by n each over n square minus 1 multiplied by A. Is this the formula we have to show? Now it's showed. Okay. Now I proved this formula. Okay. This is the good place where I can stop. Do not forget to support us by subscribing. Thank you. I will see you in next video. Bye.